All right, so back to the idea of the bouncing ball, which you can't see because I haven't turned on the projector yet. But y'all saw me write it on the board, but for the folks at home. We discussed it and think that the pseudocode I presented was incorrect, because I think the way it should work is if you drop something from a height of 40 with a index of 5 for 3 bounces, it falls 40, and then it bounces up 20 and then drops 20. That's its first bounce. And then it bounces up 10 and drops 10. Then it bounces up 5 and drops 5. And so that's 40, 50, 60, 70, 80, 90 total. So to figure that out, you'd have to ask the user for the number of bounces, which I'm not going to bother doing that input. Num bounces equals 3. The initial height, right, is 40. And the bounce index is 0.5. Got several folks missing. And so the initial distance is equal to the initial height, right? That's how it starts. And then we need a counter to go through the number of bounces, right? For I in range, parentheses, num bounces, colon. If I was going to do my normal old-fashioned variable names, I would put underscores. If you want to be new school and look modern, professional, you'd probably use uppercase letters like that, but I'm just going to go with my underscores. Old and set in my ways. All right, here we go. So each time it bounces, it needs to decrease. Like in our example, it was decreasing by half each time, but that could be based on the bounce index. If for some weird reason it had a bounce index greater than 1, it would bounce higher and higher and higher each time, which would be pretty weird. So when we ask the user for the bounce index, we probably should not allow that, but whatever. Don't need to make the program more complex. All right, so we would prompt the user for these 3 values. We would calculate the initial distance, and then for each bounce, we would say bounce index equals, wait. I think we need a new variable to hold init height, and I may be spacing out on what my pseudocode said. But let's just call it bounce is equal to the initial height. And so each time the bounce gets reduced, bounce equals bounce times bounce index, right? So for bounce index of 0.5, it would wind up being, or you could just say bounce times equals bounce underscore index, right? Either work. Then we need to add that to the distance. Distance equals distance plus bounce. But we need to make it 2 times bounce, right? Because it's bouncing up and then it's falling again. So 2 times bounce. Or if we wanted to write it short form, I misspelled distance. I have to go back. Distance plus equals 2 asterisk bounce. I don't know why I'm writing it out long form. I think just because I graded a whole bunch of papers where some people were writing that long form. And then we could put a print message, right? Print after bounce, comma, distance equals plus, or end quote, comma, distance. And heck, why not copy and paste that and make it say before bounce, distance equals. Something not looking right. I guess that's right. But is that what I wrote here? In my notes? Oh, I erased my notes. Great. So 40 and then 20 up and 20 down and then 10 up and then 10 down and then 5 up and 5 down. So that's 40 plus another 40. That's 80. and then 20 more, and then 10 more. Is that what our output look like? Yep, yep. Okay, good, good. All right, I feel pretty comfortable with that. Where'd my Lecture R go? Delete that garbage. All right, so that's the bounce problem. Somebody else had a version of Python that was not crashing if you called mode and you passed it a list of unique values. It would simply return the first value in the list.
It works on my laptop.
Works on your laptop, but not on.
Anything to it, but I had to re-download everything last week, so I'm running a new version. I don't know if it's.
Well, that could be it. That could be it. But anyways, so if by some chance, maybe it's the newest version of Python, maybe they've changed the library to not crash, not return an exception. If you're, what is the mode? It's supposed to be returning the item with the most common, occurrence in a list. If 5 occurs more often than any other value, it should return 5. And if they're all unique, it was crashing. Apparently, they've changed that very, very, very recently. That's wild.
Yeah, because I have 3.7 on my laptop.
Yeah.
And they're using 3.8 is the newest one that I had downloaded on my computer.
Yeah, okay. What do you know? I'm glad you mentioned that, though. That is really wild.
Yeah, it completely threw me.
All right, so we've talked about dictionaries. Yes, ma'am.
So I did already do this homework assignment.
You don't have to resubmit it.
Okay.
Right. I mean, you wrote it to spec. I'm going to give you full credit for it. If you feel like it, you can revise it, but
Okay.
I wouldn't bother. Unless it just nags at you late at night. You're tossing and turning, thinking, that's incorrect. Then sure, get up and re-upload it. I am joking. I'm hilarious. I amuse myself. All right, so dictionaries are association. They are like lists are, like arrays, except instead of saying, data subscript 1 is equal to, 1, 2, 3 or whatever. It's more like saying data subscript quote February end quote equals 1, 2, 3, like that. So the key can be anything, whereas an index has to be a number from 0 to n-1, where n is the length of the list. The key can be anything. You can even, in this silly language, have mixed type keys, right? One element in your dictionary could have a string there, and one could have an int, and one could have a float. That would be absurd, and I cannot think of a good reason to do that. Just like Python supports lists where you have strings and ints and floats all in the same list. You can even have lists and lists, and other languages do not support that at all. It's just that Python is pretty cool. But that's kind of weird concepts, and I'm not going to demonstrate having multiple data types in the same list. I don't see any reason to do that. So that's the idea of a dictionary. It's just an association of keys and values. So for example, say we have sales. We always love to talk about sales. Is it equal to an empty dictionary? Those are curly braces. Or if you like seeing the word DICT there followed by parentheses, that works just as well. I waffle on which one I like better. Then we could say that sales for quote Monday in quote end were 5,000. Sales for quote Tuesday end quote were a little bit less. Sales for subscript quote Wednesday end quote in subscript went to the roof, right? 9,000. 999, yeah, that looks weird. 9,000. Okay, and so on. I'm not going to fill in the rest of the days because that pretty much proves the point. What if we want just a list of the keys? Rather than, because we want to step through it and we want to get each value out of the dictionary. For key in the dictionary, you could do something with that key. So we might print a list of keys. It's like print, we have sales for space, end quote, or how about just a colon, end quote, in parentheses. And now let's use a for loop to print them out. For value, or for key in sales, colon, print the key, print the key, and then comma, end equals, quote, space, quote. What's that going to do? It's just going to stop it from going to the next line after each value. So it's going to print all the keys in a row rather than printing them one after the other on separate lines. But then after we print out the entire row, we better print out a blank line, right? Or we need to print a character turn to go to the next line. And then we could have a loop that would ask, what day they want to see the sales for. Or Q to quit. Something like that, right? So while true, colon, choice equals input, parentheses, view sales for what month, question mark, space, space, greater, end quote, in parentheses. We want to see if that month is in there. If choice in sales, colon, then it's good. Print parentheses, quote, sales for percent S R percent dot 2F. Let's put a $sign in the percent, in front of the percent, just so it looks like real money. End quote. And now we have to fill them in. We're going to use a tuple. Remember what a tuple is? A tuple is some values between parentheses. So we're going to have a percent sign, and then our tuple is going to consist of things to fill in that placeholder and that placeholder. So we need to fill it in with the value of the key, or excuse me, fill it in with the key, and then that value, which is sales subscript key in subscript in parentheses. And then we need one more close parentheses to polish it off because we also have one over here. Now I didn't say enter sales for what month or Q to quit. So I'm adding that now, or Q to quit. And then as soon as we get our choice, if choice equals quote Q end quote, then let's just break out of the loop. All right, but if it wasn't in there, we better tell them that. Else print, else colon print. No sales recorded for end quote comma key. I mean, we could be rude and say invalid key or error or whatever, but what if they typed in, here I'm calling it month, and here I have days. So why don't I say for what day? Maybe a little comment here to end while. Just keep track of things. All right, so run it. We have sales for Monday, Tuesday, and Wednesday. View sales for what day? Monday. They were $9,000. Tuesday, $9,000. Something's gone wrong. Wednesday, $9,000. Thursday, no sales recorded for Wednesday. My program's a piece of junk. What did I do wrong? Oh. Here I'm calling it choice, and here I'm calling it key. Key equals the very last thing that it printed up here. What was the very last thing in our list when we ran it? Wednesday. And so that's why I kept printing out 9,000. We could fix that by changing that word choice to key, or I could just fix it over here, right? I have 3 places to change it here, 3 places to change it here. I'm going to change it here. Instead of choice equals input, I'm going to say key equals input, and then if key equals Q, and then if key in sales. That should fix it. So I had to make 3 changes. I had to change that line, I had to change that line, and I had to change that line. All right. So Monday, 5,000. Tuesday, 4,000. Wednesday, 9,000. All right. We could have just printed a report, right? But it didn't make them do that. Q to quit. Or wait, let's type in invalid day, Thursday. No sales recorded for Thursday. And Q to quit. Okay, the program works now. What if we wanted to just print a report instead? Or we could ask them for which value to change, right? We could say sales for $ are this. What are the new sales? Yeah, let's do that. Just to make things inordinately complex, right? So, new underscore sales equals float parentheses input parentheses quote. What are the new sales for space end quote plus key plus quote question mark end quote end parentheses. And then we have to store that back, right? I seem to mess something up. I don't have enough closed parentheses. 2 closed parentheses. And then sales subscript key is equal to new sales. So now we're not just viewing them, now we're changing them. So maybe we ought to make this say change sales for what day rather than view sales for what day. Change sales for what day. And if we were going to do that, we should have displayed the sales to begin with. We should have had a silly little report to print the sales to begin with, right? We could do that. Let's put our little report up here. For key in sales, colon, print sales for, end quote, comma, key, comma, quote, R, end quote, comma. Wait, I don't need that space there. Putting the commas adds the spaces automatically. How about R? Do we want to get fancy and put $ signs and stuff? But that's going to make them think that they need to put in $ signs and stuff like that. Well, we've already got that problem. So, nah, let's keep it simple. Sales subscript key. In subscript in parentheses. So print sales dictionary. That's what we're doing there. And here, allow the user to change the values for any day. I had one final else down here that scrolled off the screen. There, that's the entire code. Pause it if you're typing along and you need to just be aware that there's one more close there that you can't see. I guess I could remove one and a couple of these things. All right, there we go. All right, sales for Monday are 5,000, Tuesday were 4,000. But change the sales for Tuesday we instead scored a big mighty 700. Then we could quit. We could get the sum of those total sales pretty easily. Again, it would be a for loop that looked remarkably like this. We can't just call sum, though. That's what we've done in the past. You can't call sum on a dictionary because it doesn't know which value you'd be adding up. I could be lying. Let's find out. X equals sum parentheses sales in parentheses. I wonder. Can't possibly work. Yeah. All right. There's probably a way to get it to work. Not going to do it. Instead, to calculate the total of the sales dictionary, again, we're going to get all the keys and just add those to a total variable. So total equals 0. For key in sales, colon, total equals total plus sales subscript key in subscript. And we could print it out if we wanted, right? Would have been nice if we'd done that after the report and if we printed it out every single time and blah, blah, blah. But that's how we could do it, right? What is the length of the dictionary? I'm hoping it's 3 because we have 3 pairs, right, of data in it. So just out of curiosity, I'm going to print the length of the dictionary and hope that it's 3. Print sales. I don't think print sales is going to, that's not going to do what I just said at all. It's not going to print the length of it. It's going to print the entire dictionary, which looks like that, which is kind of nice for us to diagnose, right? What if I change that to LEN sales with 2 closed parentheses? Three? Good. So if we wanted to calculate the average, we could use the length of the sales. Or we could just have another variable that we incremented each time, right? Like num underscore sales equals 0, and each time we get a sale, we just add it to that. Num underscore sales plus equals 1. Then we could calculate the average. Average is equal to the total divided by num underscore sales. And I didn't print it out, so whatever. This would be the good, printing the report would be a good thing to throw into a function, because then I could have just added this to the report, you know, and we could have printed the report every single time they made a change to it. All that would be a good idea. I'm not sure if I want to go back and make those changes at this point. Tempted. Why not? Take our little code here, cut that, go up to the top and paste it, and we're going to turn it into a function. So that little bit of code, print the sales dictionary, cut that, scroll up to the top, define a function. Def space print underscore sales, and we need to pass that dictionary in. So print underscore sales, parentheses sales, in parentheses colon, paste those guys and tab them over. If we wanted to do Java doc style comments, we could put triple quotes around our comment there. Let's take our average and our sum code and make it part of that function as well. So the very last stuff that we added, go and cut that and paste it right here as well and tab it over. Make sure it's all tabbed. Remember, you can highlight a whole bunch of lines and hit the tab key to get them all popped over at once. If you feel like it, you could add the return keyword at the end of your function, or you can leave it out if it's not actually returning anything. It does the same thing. Remember that if you don't stick anything here of some kind of value, it instead returns a magic word, none, with a capital N. All right, we have our print sales function. Why don't we go and stick that inside our for loop here? Right here. Right? Print underscore sales, parentheses sales in parentheses. We really don't even need this thing anymore, as far as I'm concerned, because they can see what days we have. All right, so I made a bunch of changes. I better walk about and make sure everybody's doing okay, but let's see if it runs. All right, change for what day? Monday. They sold $1 worth. Did I really not make it print the total? Dadgum. Yeah, I calculated it. I never printed it. Alrighty. So print parentheses quote total equals $%.2f. Average equals $%.2f. End quote. And now we have to pass in a tuple to fill in those two placeholders. So we need our %sign and a pair of parentheses and a closing parentheses. And inside the pair of parentheses, we need to fill in these two placeholders with the words total and average. Total, comma, average. All right. Sales for Monday became $1. New average, new total. Sales for Tuesday, 0. Sales for Wednesday, 0. Average $1. Q. All right. So from the top, here's the top. Pause it if you're at home. Type it in. Eyeball your mistakes. Here's the next part where we set stuff up. This was for the bounce problem. You could ignore all that if you're not worried about the bounce problem. Here's where we initialized our sales. You know, we could have inserted them and made them random values or asked the user for them or read them from a file. All right. Then we have this. So what if we wanted to read data from a dictionary? I mean, not from a dictionary, from a file. And then add that data to a dictionary. Like say we wanted to read this program and find out how many times each letter occurs. Well, let's do that. What we're going to do is we're going to open this file. Maybe we'll ask for the file name. Maybe we'll hard code it. And then we're going to read the entire file, pulling out every letter in the file and keeping track of how many times those letters occur. But firstly, let's demonstrate that with a shorter task. So if our string is this, you know, and we want to build a frequency count for that. And I know we did something similar to this, but it's important enough that I don't mind reiterating it. So let's create our frequency table. Frequency equals open brace, close brace. And now let's step through that. Since this is a string and not a list, I can't just use a for each loop. Instead, I'm going to have to use an index-based loop, subscript loop. So for I in range, parentheses, len, parentheses s, close parentheses, colon. Let's get that character out. Character equals s subscript I. And let's check to see if that character is already in the dictionary. And if it is, we're going to increase that value by 1. If it's not, we're going to set it equal to 1 because it's the first time we found it. So, if char in frequency colon FREQ, not the whole word frequency unless you type that, then we're going to get that value and we're going to add 1 to it, right? Count. Now let's just do it in 1 line rather than 3 lines. Frequency for that character plus equals 1. Else we have to set it to 1, meaning that we've never found it. So else colon frequency subscript char equals 1. First time we find it, it's not in the dictionary, we say, okay, we found it. This is the first time we set it to 1. After that, we start increasing it. That's the end of our loop, and we could print it out. So for key and frequency, colon, the value is equal to the frequency subscript key. And then we print parentheses, quote, %s occurs %d times. And it's always annoying to see it say 1 times, right, with an s, plural, but we're not going to bother fixing that. End quote, %, open parentheses, close parentheses, and inside our tuple, we need to fill in s with the key. And we need to fill in, whoops, I forgot to put a variable. What, a placeholder there. What kind of placeholder should I use? These are pretty much going to just be integers, right? 1, 2, 3, 0. Well, not 0 because nothing's going to occur 0 times. So if it's an integer, what placeholder do I use? %s is for strings, %f is for floats.
%d.
Yep, %d. There we go. And so key, comma, value. I didn't print anything. Yeah, there we go. Print A, B, D, F, S, and then a space. Maybe we only want to do this for letters and numbers and not the special symbols, right? Because we're going to open our program and it's got parentheses and close parentheses and stuff like that. Or maybe we want to ignore spaces or something like that. Let's do that. Let's ignore white spaces. I need to remind myself how to do that, but what we're going to do is we're going to have an if statement here. If the char dot, and it's something like is space or is white space or something. Let's Google that up. Really? Okay. Is space. Returns true if it's a white space character. A true is a tab, the space bar, and the enter key. So, if char dot is space, parentheses in, parentheses, colon, continue. That means skip everything. Immediate. You know what break does? Break causes it to exit the loop immediately. Continue causes it not to exit it, but to skip back to the top. So now it's not going to show any occurrences of spaces in our string. Cool. We're going to take the same concept and we're going to apply it to opening the file and reading in all the data. It's going to look very similar to this though. But we need to wipe out our frequency dictionary. We're done with it. We're going to create a new one. Frequency equals open curly brace, close curly brace. Let's get our file name is equal to, and I'm just going to open my lecture file, lecture R.py. Make sure you get it exactly matching that. This might not work if you're not using idle. People using PyCharm are having trouble with where it was storing the default files, but you can accommodate that, or you can just skip this part, but I'm sure you can figure out how to hard code a path in here that it will work with. Alright, let's open the file. File equals open, parentheses, fname, comma, quote, R for reading, end quote, in parentheses. And now let's process every line in that file. For line in file, colon, we're just going to do this stuff. We might even wind up copying and pasting that stuff. Let's say S is equal to the line, and then let's strip it so that there's nothing at the beginning of it or at the end of it. We don't even really need to strip it because we're checking for white spaces. But S equals S.strip, remove spaces from beginning and the end of the line. And then we can just take this stuff, copy and paste it, and tab it over. So from the for loop all the way down to the last thing there, tab that over. Now let's close the file. And let's print our table out like we did right here. So I'm just going to take that little blip of stuff and paste it. Alright, and so it opened the program, it read it. Lecture RDF. So they're kind of in order of insertion. That's kind of what we're seeing here. What if we wanted it to be sorted alphabetically? Well, that's just the thing that I always Google every single time I need to know how to do it. I'm not expecting you to remember it, but I'm expecting you to remember that you could Google it if you wanted to. Print Python dictionary sorted by key. I don't like that. Don't really like that. That's looking alien to me. Using JSON's not what I'm hoping to see. There we go. That's what I wanted to see because it follows the kind of stuff that we already know how to use. It uses a built-in function called sorted. So it sorts the items in the dictionary. So to get that to work, all we're going to need to do, let's just copy our little report here. Print parentheses, report of frequency sorted by keys, or by key, end quote, end parentheses. It's going to be the same little loop, but it's going to be for key in sorted parentheses frequency dot, and I have to cheat. My long-term memory is not good enough just to remember. From one moment to the next. Dot items, open parentheses, close parentheses. So freq dot. That's going to sort it by value. I don't think this is going to work. I think it ought to say dot keys. Don't know why I have a semicolon there. I was thinking in terms of Java. attributes.keys. I'm just going to copy and paste that line. Hope it works. Of course, I'll have to change the variable name. Keys equals sorted frequency.keys. Oh, I see. I just didn't put the S there. Let's just do that. If that'll do it. All right, and there they are sorted by their key value, right? And according to the ASCII table, special symbols like $ and parentheses and stuff occur before the numbers, which occurs before the letter, uppercase letters, which occurs before the lowercase letters. Well, that's all well and good, but what if we wanted them sorted by value? That's probably what that other chunk of code was trying to get us to go towards. So there is something called an order dict, which remembers the order in which the elements have been inserted, but that wouldn't have done us any good because we wanted them sorted by, not the order in which they were inserted, but their real letter value, A, B, C, D, and stuff like that. All right, get sorted list of keys from dictionary sorted by value. Again, it's looking pretty alien. I wish I had this memorized. That would do it. I'm going to copy that. I can tell this is Python 2 though, rather than Python 3. Easiest way to tell that it's Python 2 is that the print statement does not have parentheses. But it might work. Let's find out. So this is printing sorted by key. We're going to do the same thing, sorted by value. So just copy those lines one more time. But I need to modify this line to kind of look like this. Sorted frequency, comma, key equals frequency.get, comma, reverse equals true. We want them big numbers up at the top. Well, that might make sense. The most commonly occurring letters we might want up at the top. So reverse equals true. I hope this works since we're taking the time to type it. Find out. And it worked. Lo and behold. I need to change that to say sorted by value, but E was the most common. S and R followed. Now that's fairly, it's true that if you need to figure out, if you just have a book and you counted the number of times each letter occurs, you'd probably find that E, S, or R occurred the most often. There is some book. Let me see if I can remember the name of it. Not that this is really germane, but Gadsby book does not contain the letter E. So somebody wrote an entire book without the letter E in it. How would you do that? Can't have the word the in it, for example, or he or she. So anyways, that's quite a feat since it's one of the most commonly occurring letters. I want to change that to say report to frequency sorted by value. Why reverse true? Because we wanted them with the most often occurring at the top. All right. Now that's just kind of magic syntax that I have to look up every time I need it. And so once or twice this semester I have to go back and remember how to do that, so I have to Google it. Let's add a print statement to this as well, saying what it is. This was a little report, a frequency, unsorted. Right? We didn't sort by key, we didn't sort by value. It would be interesting to find out what sorted parentheses frequency underscore keys actually does. So I'm going to run it and then into the shell. I'm just going to type that. Okay, fine. All right, it's a list of strings containing all the keys. That one's pretty clear to me, how that one works. You could probably put any kind of list in there. How's about this one? Not going to work on figuring that one out. All right, that may be enough about dictionaries, except how to remove elements from the dictionary. To delete an item from a dictionary, remove its key using pop. Okay, really? That's a stupid word to use in order to remove something from a dictionary. I would like a better choice, although that's what the book says. Dict pop. It's one way. Or using DEL. I'd rather do that. To me, that just makes more sense. Book says to use pop to remove elements from the dictionary. Prof likes DEL like this. We don't need to know how many times E, S, and R occur in our dictionary, in our frequency table. So DEL, frequency, subscript, quote, lowercase e, end quote, right? And I could remove the R as well, or whatever. Why do I like that syntax? Because that's the same syntax you use to delete from a list. If you declare a list, L equals square 1, 2, 4, 5 n square. And if you want something gone from it, DEL, L subscript 0, n subscript should remove it. Yeah. So what does this do? It removes the key value pair for key E. And that does the same thing for R. All right, so on Tuesday, I'm going to introduce the idea of semester projects. I'm going to try not to make them killer, because really, counting Thanksgiving, got like 4 weeks left. This is week 11, 12, 13, 14, 15, 16. Skip Thanksgiving, that's 4 weeks to do a project. They're not going to be killer. They're just going to be little programs. Some of them more difficult than others. I want you to pick programs that you think you'll be able to do in the time that you want to allot for it. You'll get 100 on it whether you write 1,000,000 lines for it or whether you write 100 lines for it, as long as those 100 lines finish the project. One of the project offerings will be to write Hangman, and I will mention that every time I offer Hangman as a project, until I started giving this warning real vigorously, somebody would always go off on the internet, copy Hangman, paste it, and submit it. Every semester it was happening. It's just because there's 20,000 different Hangman implementations out on the internet. And you get to the last week, you hadn't worked on your project, you go, oh man, crap. You'd go and Google up a Hangman program and you'd submit it, and then big bad things would have to happen. So, I will just say, don't take Hangman code off the internet. If you need help writing a Hangman project, ask me for the pseudocode, and I'd give you pseudocode for it and make it pretty dang easy. So that's actually probably the easiest project if you ask for the pseudocode. And there'll be some other project ideas. One of them is going to be something kind of like this, where you open up a file, you analyze it, and then you print out a little bar graph of all the letters, right? E occurred this many times, A occurred that many times, B occurred that many times. But you're going to probably want to use the turtle library in order to do that. We need to introduce the turtle library if we have not already done so. I think we will do that on Tuesday as well. That'll be another project. And then another one is the idea of a game where you have two fighters, like in Dungeons and Dragons or something like that, and they each have stats. They have an attack strength and they have an armor, and they keep fighting until one of them wins, right? And by fight, I mean, generate random numbers, just like you were rolling dice for each one to see who had the better attack and what happens. Some people like that one, and one person turned that into a Pokemon program, where you could pick from a list of Pokemon, and they each had different attacks. And some Pokemon were more, vulnerable to fire attacks than others. And so they actually put in a whole bunch of work into that one. That was kind of cool. You don't have to go above and beyond like that, but the more interesting you make your project, perhaps the more you learn from it. So we'll talk about that on Tuesday. We done with the chapter? We've done dictionaries. Removing keys. Yeah, sure. This is an interesting idea, though. When you're removing it with pop, you could remove it by its key, but you could also... Why in the world would you want to specify the value that you were deleting? Now, in Java maps, which are about the same thing as dictionaries, when you're deleting something, you can give it both a key and a value, and if it doesn't match both of them, it won't delete it. That could be what this is saying. Print all the keys and their values, you use a for loop. Or there is something called items. Method called items returns a list of items. That would be interesting to work with. Let's stick that into our code, just to eyeball it. So, for value in frequency colon items, parentheses in parentheses, colon, print, parentheses, value in parentheses. Let's see what that looks like. And it gives us a whole bunch of tuples. Tuples are the things that are surrounded by parentheses, a whole bunch of pairs. That's the key, and that's the value that's associated with it. So when we were doing these sorts, nope, we weren't calling dot items to get them, although some of the solutions we saw when we were Googling. By the way, it's totally okay to go and Google code. When I was talking about, failing you on your project because you went and you Googled the answer, it's not okay to go and Google an entire assignment. That's like Googling, a term paper and submitting it in. But when you're writing a term paper, you're probably going to be doing some research, and search engines are certainly, Programmers Google all the dang time. It's just that you don't go and take huge blocks of code unless it's open source code, and that's not the point of this class. You're not going to go and find open source Hangman implementations, although they're out there. You just need to learn enough to write it yourself. So, not dissing the idea of Googling for help. I'm dissing the idea of turning in something that you find on the internet. Seems like low energy today. I think the talkative people are gone. I should have brought y'all all Red Bull, made you all hyped up and caffeinated. Oh, and here it is. Here it is. I didn't even have to Google it because they tell us how to do it right here. Do we like this method better than the other one? This is kind of neat. I should have gone with this. Get a list of the keys. Sort that list. And then use that. That's pretty dang cool, and I should have done that instead. Now, it doesn't sort it by value. Can you call dot values and get the same idea? Let's try that out. I need to look at that page slightly more. Short-term memory shot. List parentheses, whatever dot keys. Okay. So S1 equals frequency, or list parentheses, frequency dot keys, open parentheses, close parentheses, close parentheses. Now let's see if we can get values out the same way. S2 equals list frequency dot values, parentheses, in parentheses. And then we could print them out. Print S1, S2. Yeah, sure enough. It got all of the keys out of the dictionary, and then it got all the values out of the dictionary. Are they sorted? No, they're not. Okay. But you could sort them if you wanted to. Right, S1.sort, S2.sort. Now this, you would not want to sort the values, but if you wanted to, there you go. So, like it. I like that method better. Keys equals list parentheses frequency dot keys, open, close, close. Keys dot sort, parentheses in parentheses, for key in keys colon, print the key comma, and then the frequency subscript key in subscript in parentheses. Alright, I am going to burn that into my brain so I don't have to look it up. I'm still not sure I will be able to sort the values in the same way. Alrighty, so there we go. They're again sorted by their key. And I like that syntax a lot better. I might even go and secretly go and delete this part, but nah. Let's just add a little note. This is the book way of printing the dictionary, sorted by key. Prof likes it. That's what I'm going to remember how to do from now on. Alright, so things you can do with the dictionary. You can call len on it. You can call .get. You can call .pop to remove it. This is interesting in as much as if you call .get and the key does not exist, you can get a default value out of it. So if you specify a dot value, now I see why when you call pop, you can specify a default value. Back when we were doing our days and our sales, instead of checking to see if the key was in the sales, we could have taken advantage of that. We could have done something as similar as, as simple as this. I don't know that I want to actually change this code. Could have done if key equals quote q colon break, and then we could have done value equals sales subscript key, or sales.get for that key with a default of none. And then we could have printed out the sales for it. I'd rather you do it this way. I'd rather you get used to checking to see if something is in the dictionary rather than pass out a dictionary value. And I'm also not fond of using the .get method to get it out because it kind of breaks the idea that dictionaries and lists are accessed the same way. Except that with lists you use numeric subscripts, and with dictionaries you use any kind of dang subscript you want, whatever matches the keys. .clear will wipe out your list or your dictionary. List, you can retrieve an item, a list of items, which are those pairs, those tuples. List keys, you can get a list of keys. List values, you can get a list of values. For key in dictionary, that lets you step through it with a for loop. You can keep a hex to binary lookup table to aid in the conversion process. Here's your table. They're making a dictionary. We know they're making a dictionary because it's got curly braces. But rather than doing a whole bunch of assignments, they're actually creating it on the spot with the initializer, just like we do sometimes with lists. Sometimes with lists we do this, right? L equals, like that, and then we put some values in there. You can do the same thing with dictionaries, but the syntax is pretty nasty. You can see the example of the syntax there. If I was going to do a hex to binary table, I would probably go ahead and just add them. Something like this, hex bin equals, and create an empty dictionary, and then hex bin for 1 is 0000. Hex binary for, no, that's for 0, right? And then for the number 1 is 0001. I would just keep doing that for all 16 characters of the hexadecimal set, right? So 2 is an 0010, a 3 is an 0011, and so on. And I'm not going to do the other, I'm not going to go out to F, although it would be vaguely interesting to do. And then if you wanted to, you could get the binary sequence based on the digits. So if we had some string that looked like this, S is equal to, 0, 3, 0, 2, 0, 1, 0, 0, and we wanted to print out the binary digits for that, it would be pretty easy. You'd use an index-based loop to step through your string. For I in range, parentheses, len, parentheses, s, close, colon. Get that character out. Character equals s subscript I. And then get the matching of that. The match, the result, the hex, is equal to hex bin subscript that character. Then you can print that out. Print hex comma END equals open quote, close quote, or if you like seeing spaces between your clusters of hex digits, like that. And so it's just going to print out all the binary values of these. There are certainly other ways of doing this. It blew up. Key error. I botched that. What should the syntax really be?
It should be single quotes, right?
Single quotes, double quotes are interchangeable in this language, but I know where you're going with it because in some languages you have to have single quotes there. My problem is I didn't do it in the correct assignment syntax, which is that. So I apologize for that. Fortunately, I only made 4 of them. It's pretty easy to fix them. And we're about done for today. And there's my binary representation of those hexadecimal numbers. I need a final print. All right, I'll go back to that in a minute if you need to look at it a little more, but I want to check something. Does this look reasonable? Write a loop that lets the user enter name, and it will append it to a list called names. The list should repeat 5 times. Then print the contents of that list using that. This is looking pretty elementary. Then print it like that. And then create a list of squares using a for loop that is a list of the squares of the numbers of 1 through 9. Use squares.append to create it. No, now it's not so trivial. When you print the list, the value should look like this: 0, 1, 4, 9, whatever. So you're going to need to use that end clause most likely. You can figure out how to print it. And print the squares loop using a for loop, which should produce the results shown above. All right, I think that's reasonable homework. I haven't already had one where we created a list of squares, have I? That's not sounding familiar, because I don't want to arbitrarily recreate it. In fact, that's the most interesting part of this. But I want you to do that as well. Okay, so that'll be our homework assignment. Any questions? Let's make a Dropbox so you can scamper out. Then I'll ask for questions again.